The dawn of weaponized technology, how everyday devices became instruments of war. In an age where technology seamlessly integrates into every aspect of our daily lives, the boundaries between civilian convenience and military vulnerability have become increasingly blurred. The September 2024 attacks across Lebanon and Syria marked a terrifying evolution in modern warfare, demonstrating how ordinary communication devices could be transformed into sophisticated weapons capable of inflicting mass casualties. This unprecedented incident, which intelligence sources later revealed as Operation Grim Beeper, represents a fundamental shift in how we must perceive the intersection of cybersecurity and physical safety in our interconnected world. The concept of cyber-kinetic warfare has evolved from theoretical academic discussions to a stark reality that demands immediate attention from governments, technology companies, and civil society. Unlike traditional cyber attacks that target data or disrupt services, cyber-kinetic operations blur the line between digital manipulation and physical destruction, creating new categories of threats that existing security frameworks struggle to address. The weaponization of everyday consumer electronics represents perhaps the most insidious evolution of this concept, as it exploits the fundamental trust relationships that underpin modern technological society. Understanding cyber-kinetic warfare. The term cyber-kinetic warfare describes military operations where cyber capabilities are employed to create physical effects in the real world, ranging from infrastructure damage to human casualties. This concept was first formally articulated by security researcher Scott Applegate in his prescient 2012 paper, The Dawn of Kinetic Cyber, which warned of the growing convergence between digital vulnerabilities and physical consequences as cyber-physical systems became more prevalent in critical infrastructure and everyday life. Traditional cybersecurity frameworks focus primarily on protecting data integrity, system availability, and user privacy. However, cyber-kinetic attacks introduce an entirely different dimension of risk assessment, as successful operations can result in tangible physical harm, property damage, and loss of life. This evolution represents a fundamental paradigm shift from viewing cyber threats as primarily economic or intelligence-gathering activities to recognizing them as potential instruments of warfare capable of producing battlefield-level casualties. The progression from purely digital cyber operations to cyber-kinetic attacks reflects the increasing integration of computing technology into physical systems. As more devices become connected and controllable through digital networks, the potential attack surface for cyber-kinetic operations expands exponentially. Industrial control systems, medical devices, transportation networks, and communication infrastructure all represent potential targets for adversaries seeking to leverage cyber capabilities for kinetic effects. The anatomy of Operation Grim Beeper. On September 17, 2024, the world witnessed an unprecedented demonstration of cyber-kinetic warfare when thousands of pagers simultaneously exploded across Lebanon and Syria. The devices, identified as Gold Apollo AR-924 models, detonated with lethal precision, killing at least 12 people and injuring thousands more. The following day, walkie-talkies experienced similar coordinated explosions, adding approximately 30 additional fatalities and hundreds more casualties to the devastating toll. The tactical execution of these attacks revealed a level of sophistication that redefined the possibilities of supply chain manipulation and device weaponization. Intelligence reporting later revealed that Israel's Mossad intelligence service had orchestrated the operation over the course of more than a decade, demonstrating the long-term planning and resource commitment required for such complex cyber-kinetic operations. The operation involved the establishment of elaborate shell companies, sophisticated supply chain infiltration, and the development of explosive devices disguised as legitimate communication equipment. The devices themselves were engineered to appear completely authentic, complete with proper branding, documentation, and functionality that would pass casual inspection. The explosive components were integrated so seamlessly into the device architecture that they remained undetectable through normal use and basic security examinations. This level of technical sophistication required extensive knowledge of electronics manufacturing explosive engineering, and supply chain logistics, representing a convergence of multiple specialized capabilities rarely seen in traditional military operations. The triggering mechanism employed in the attacks demonstrated particular psychological sophistication. The pagers were programmed to emit urgent notification signals and display messages that prompted users to handle the devices at the moment of detonation. This behavioral manipulation ensured that victims would be in close proximity to the devices when they exploded, maximizing casualties while minimizing the possibility of premature discovery. The coordinated timing of the explosions across multiple geographic locations further demonstrated the operation's technical complexity and strategic planning. The immediate aftermath of the explosions overwhelmed medical infrastructure throughout the affected regions. Hospitals in Beirut, the Bekaa Valley, and southern Lebanon reported unprecedented casualty loads, with medical personnel struggling to treat victims suffering from severe facial injuries, eye damage, traumatic amputations, and blast-related trauma. The attack's targeting of communication devices meant that many victims were caught completely off guard, often suffering injuries while engaged in routine daily activities or professional duties. Strategic and tactical implications. The strategic implications of Operation Grim Beeper extend far beyond the immediate casualties and tactical disruption it achieved. The operation fundamentally weaponized trust, exploiting the basic assumption that communication devices procured through established channels would function as intended without posing physical danger to users. This breach of technological trust creates lasting strategic effects that persist long after the immediate physical damage has been addressed. From a tactical perspective, the attack succeeded in simultaneously degrading enemy communication capabilities while inflicting psychological trauma on a much broader population. The targeting of communication devices specifically chosen by the adversary for their perceived security advantages demonstrated a level of intelligence penetration that calls into question fundamental assumptions about operational security. The operation forced Hezbollah and other regional actors to completely reevaluate their communication security protocols, creating lasting disruption to organizational effectiveness. The psychological dimensions of the attack proved perhaps as significant as its immediate physical effects. By demonstrating the ability to weaponize everyday technology, the operation created a climate of technological paranoia that extends far beyond the immediate target organization. The uncertainty about which devices might be compromised forces potential targets to expend significant resources on verification and security measures while constantly questioning the reliability of their technological infrastructure. The operation also demonstrated new possibilities for asymmetric warfare, where technologically advanced, actors can leverage supply chain access and manufacturing capabilities to project power against adversaries who lack equivalent defensive capabilities. This model potentially provides smaller, technologically sophisticated states with force multiplication capabilities that were previously available only to major military powers. Legal and ethical dimensions. The legal and ethical implications of weaponizing civilian communication devices raise fundamental questions about the applicability of existing international humanitarian law to cyber-kinetic operations. International legal experts and human rights organizations have condemned the attacks as potential violations of the laws of armed conflict, particularly the principles of distinction and proportionality that require combatants to differentiate between military and civilian targets and to ensure that anticipated military advantages outweigh potential civilian harm. The indiscriminate nature of the device explosions presents particular challenges for legal analysis under current international law frameworks. The explosive devices were programmed to detonate regardless of who was using them or where they were located, making it impossible to verify whether the immediate victims were legitimate military targets or civilian bystanders. This technical characteristic of the weapons raises serious questions about whether such attacks can ever comply with international humanitarian law requirements for discrimination in targeting. United Nations officials and international human rights organizations have called attention to the precedent established by weaponizing civilian communication technology. The attacks demonstrate how consumer electronics can be transformed into indiscriminate weapons that pose ongoing risks to civilian populations long after their initial deployment. This weaponization of civilian technology threatens to undermine global communication infrastructure and international commerce in electronic devices. The international legal community faces significant challenges in developing appropriate regulatory frameworks for cyber-kinetic weapons that exploit civilian technology. Existing arms control treaties and international humanitarian law were developed primarily to address conventional weapons and military-specific technologies. The integration of weapons capabilities into civilian devices creates definitional and enforcement challenges that current legal frameworks are ill-equipped to handle. Legal scholars debate whether such attacks constitute terrorism, war crimes, or represent entirely new categories of international legal violations requiring novel regulatory approaches. The cross-border nature of modern supply chains and the difficulty of attributing responsibility for complex cyber-kinetic operations further complicate efforts to establish clear legal accountability for such attacks. The broader cyber-kinetic threat landscape. Operation Grim Beeper represents just one manifestation of a broader trend towards cyber-kinetic warfare that has been developing over the past 2 decades. The 2010 Stuxnet attack against Iranian nuclear facilities established the template for using cyber capabilities to cause physical destruction of critical infrastructure. Stuxnet demonstrated how malicious software could manipulate industrial control systems to cause centrifuges to destroy themselves. Achieving strategic objectives through cyber means that previously would have required conventional military action. The proliferation of Internet of Things devices and smart technology has exponentially expanded the potential attack surface for cyber-kinetic operations. Medical devices, automotive systems, industrial control networks, and critical infrastructure increasingly rely on networked computing systems that could potentially be manipulated to cause physical harm. The Department of Homeland Security and other security agencies have identified cyber-kinetic threats to critical infrastructure as among the most serious national security challenges facing modern societies. Academic research has identified numerous potential vectors for cyber-kinetic attacks beyond the high-profile cases that have received public attention. Researchers have demonstrated proof-of-concept attacks using acoustic manipulation of hard drives, ultrasonic interference with medical devices, and electromagnetic manipulation of automotive systems. These research findings suggest that the creative potential for cyber-kinetic attacks is limited primarily by attackers' imagination and technical capabilities, rather than by fundamental technological constraints. The convergence of artificial intelligence, machine learning, and autonomous systems creates additional opportunities for sophisticated cyber-kinetic attacks. As devices become more autonomous and capable of making independent decisions based on sensor inputs and algorithmic processing, the potential for manipulating their behavior through cyber means increases correspondingly. Autonomous vehicles, medical robots, and industrial automation systems all represent potential targets for cyber-kinetic manipulation. The globalization of technology supply chains creates systemic vulnerabilities that sophisticated adversaries can exploit for cyber-kinetic attacks. The complexity of modern electronics manufacturing means that components from dozens of different suppliers may be integrated into a single device, creating multiple opportunities for malicious actors to introduce compromised elements. The difficulty of verifying the integrity of every component in complex supply chains makes comprehensive security assurance extremely challenging for even the most security-conscious organizations. Hybrid warfare and strategic competition. Operation Grim Beeper exemplifies the characteristics of hybrid warfare, which combines conventional military capabilities, cyber operations, information warfare, and economic pressure to achieve strategic objectives while avoiding traditional military confrontation. The operation demonstrated how cyber-kinetic capabilities can be integrated into broader strategic competition between state actors, providing options for projecting power and achieving political objectives without triggering conventional military responses. The attribution challenges inherent in cyber-kinetic attacks provide plausible deniability that makes them attractive tools for state actors seeking to avoid direct confrontation while still imposing costs on adversaries. The complexity of cyber-kinetic operations often makes definitive attribution difficult, allowing attackers to achieve strategic objectives while minimizing the risk of retaliation or international sanctions. The use of civilian technology as a delivery mechanism for cyber-kinetic attacks represents a particularly insidious form of hybrid warfare that exploits the interconnected nature of modern societies. By weaponizing devices that are essential for communication and coordination, such attacks can disrupt social and economic activities far beyond their immediate military targets. The psychological impact of demonstrating the ability to weaponize everyday technology creates lasting effects that persist long after the immediate physical damage has been repaired. The international nature of technology supply chains provides opportunities for state actors to project power globally through cyberkinetic operations without maintaining a physical military presence in target regions. The ability to compromise devices during manufacturing or distribution allows attackers to position cyberkinetic capabilities worldwide, creating a form of forward-deployed capability that exists entirely within civilian infrastructure. Defense and mitigation strategies. Developing effective defenses against cyberkinetic attacks requires a comprehensive approach that addresses technical, procedural, and policy dimensions of the threat. Supply chain security emerges as perhaps the most critical defensive requirement, as the integrity of devices from design through delivery determines their susceptibility to weaponization. Organizations must implement rigorous vetting procedures for suppliers, enhance traceability requirements throughout the manufacturing process, and develop technical capabilities for detecting unauthorized modifications to electronic devices. Device hardening represents another essential defensive strategy that involves incorporating tamper detection and evidence capabilities into electronic devices. Modern smartphones and security-sensitive equipment increasingly include sensors and seals designed to detect unauthorized access or modification. Expanding these capabilities to a broader range of consumer electronics could help users identify potentially compromised devices before they pose safety risks. Behavioral training and awareness programs must evolve to address the realities of cyberkinetic threats in everyday technology use. Users in high-risk environments need education about the potential for device weaponization and practical guidance for verifying device integrity. This training must balance security awareness with practical usability to avoid creating paralyzing technological paranoia that prevents effective use of essential communication tools. International cooperation and information sharing represent critical components of cyberkinetic defense strategies. The global nature of technology supply chains and the cross-border implications of cyberkinetic attacks require coordinated responses that transcend national boundaries. Developing mechanisms for sharing threat intelligence, coordinating incident responses, and establishing common security standards will be essential for creating effective defenses against sophisticated cyberkinetic operations. Investment in detection and analysis capabilities specifically designed for cyberkinetic threats must complement traditional cybersecurity approaches. While conventional cybersecurity focuses primarily on software vulnerabilities and network security, cyberkinetic defense requires capabilities for detecting hardware modifications, analyzing device behavior for anomalous patterns, and identifying potential weaponization signatures in electronic devices. Regulatory and legal frameworks. The emergence of cyberkinetic warfare as a significant threat requires the development of new legal and regulatory frameworks that address the unique challenges posed by weaponized civilian technology. International treaties and agreements must evolve to specifically address the weaponization of consumer electronics and establish clear prohibitions against targeting civilian communication infrastructure for military purposes. Existing arms control frameworks provide limited guidance for addressing cyberkinetic weapons that exploit civilian technology. The dual-use nature of electronics components and the difficulty of distinguishing between legitimate devices and weaponized variants create significant challenges for traditional arms control verification and enforcement mechanisms. New approaches to arms control must account for the unique characteristics of cyber-kinetic weapons while maintaining the effectiveness of existing frameworks for conventional weapons. Regulatory requirements for technology manufacturers must evolve to include security considerations that address potential weaponization threats. This may include mandatory security testing, supply chain verification requirements, and design standards that incorporate tamper resistance and detection capabilities. However, such requirements must be balanced against cost considerations and the need to maintain innovation and competitiveness in global technology markets. International cooperation mechanisms must be established to facilitate rapid information sharing and coordinated responses to cyberkinetic attacks. The global nature of technology supply chains and the potential for cyberkinetic attacks to affect multiple countries simultaneously require international frameworks for cooperation that transcend traditional military and law enforcement coordination mechanisms. Future implications and conclusion. Operation Grim Reaper represents a watershed moment in the evolution of modern warfare, demonstrating how the increasing integration of technology into daily life creates new vulnerabilities that sophisticated adversaries can exploit for strategic advantage. The operation's success in weaponizing consumer communication devices establishes a precedent that will likely inspire similar attacks and force fundamental reconsiderations of technology security across multiple domains. The long-term implications of cyberkinetic warfare extend far beyond immediate military and security concerns to encompass broader questions about technological trust, international commerce, and the social contract between technology providers and users. The demonstration that everyday devices can be weaponized undermines fundamental assumptions about technological safety that underpin modern society's relationship with electronic devices. As we advance deeper into an era where cyber-physical systems become increasingly prevalent and sophisticated, the potential for cyberkinetic attacks will continue to expand. The convergence of artificial intelligence, autonomous systems, and ubiquitous connectivity creates new opportunities for creative adversaries, while simultaneously increasing the potential consequences of successful attacks. Society must develop comprehensive approaches to cyberkinetic defense that address technical, legal, and social dimensions of this evolving threat landscape. The challenge of defending against cyberkinetic attacks requires unprecedented cooperation between government agencies, private sector organizations, international institutions, and civil society. No single entity possesses all the capabilities necessary to address the complex technical, legal, and social challenges posed by weaponized technology. Success in managing cyberkinetic risks will depend on developing new models of cooperation that leverage diverse expertise while maintaining appropriate security protections. Operation Grim Reaper serves as both a warning and a call to action for all stakeholders in our increasingly connected world. The weaponization of everyday technology represents a fundamental challenge to the assumptions that underpin modern technological society. Meeting this challenge will require sustained commitment, creative thinking, and unprecedented cooperation across traditional boundaries of responsibility and authority. The stakes could not be higher, as the failure to develop effective responses to cyberkinetic threats could undermine the technological foundations of modern civilization itself. If this video resonated with you, please like, subscribe, and hit the bell icon. Drop a comment. Should there be international laws off limits for weaponizing civilian tech? I'd love to hear from you. Until next time, stay sharp and stay safe.